Hello, and welcome to the second demo for the BasePass application. My name is Trevor Howitt, and starting this demo, we're going to start with our first section. We're going to look at the application context and planning of the last two sprints of the development of the BasePass application. So first off, a quick refresher over what the application is and why it exists. So Base Paths is a baseball road trip planning application. It is meant to be a tool for people who are planning road trips and would like to see Major League Baseball games. It is not meant to encompass all of the road trip planning. It is simply meant to help with finding games to visit while you're on your trip. Um, the system is needed because planning trips to see Major League Baseball games can be difficult and inefficient. I am one person who enjoys going on these trips, and I've met many other people on these trips, and we all share that same difficulty in balancing the schedule and finding which teams are at home and which teams are away. So this system allows you to enter some dates and have it generate which games are nearby and along the route. So how will the system be used? So as mentioned, it'll build trips through a local application via the web browser. So it runs locally on a machine and is accessed with the web browser. And then who's going to benefit from the system? It'll be baseball fans such as myself who are looking to maximize games seen during a vacation. So moving on to our software requirements. So the backlog splits 13 requirements into 11 user stories. All we'll talk more about that kind of as this presentation goes on, and especially at the end. So the first half of this in sprint 1 and 2, we covered user story 1 to 10 and 11, which covered some basic system setup as well as deployment and loading seed data, and then allowing users to log in and log out and create accounts for our application. In the last two sprints of this project, we covered user story 4, 6, 7, 8, and 9. So sprint 3 covered 4, 6, and 7. This regarded creating trips, generating trips, and viewing trips. And then Sprint 4 covered 8 and 9, which were deleting and editing trips. Sprint 4 also had a heavy amount of documentation work. Sprint 3 had some documentation work as well, but Sprint 4 was really heavy in documentation, including preparation for this demo, and as well as some rollover from Sprint 3. The process has been refined each sprint to establish a steady pace that maximizes efficiency. As sprints have progressed, that kind of flow has gotten under wraps. For example, I've come up with a little bit of a loose weekly outline of how to tackle tasks for each user story. So I can usually knock out a user story depending on how big it is in a week. So working on the back end first, then the front end, and then testing. Some longer than others. I typically move past it after a week and then revisit it at the end of the sprint should there be time. So yeah. So moving on, a quick overview of our software architecture. A more detailed look at this architecture can be found in the architecture design document. And if you want to go back to the requirements as well, the more detailed look at this is in our software requirements specification. So in our architecture, in the architecture here, there are 5 non-functional requirements whose main focus is on usability, maintainability, portability, and security. Our architecture is shaped by these non-functional requirements, which in turn are formed from different business goals and engineering objectives. So our application uses 3 main technologies. This is a simplification. Uses Docker, React UI, and Java Spring Boot for the backend. The database here is not listed, but it uses PostgreSQL. And then we're looking at a layered architecture for our backend. So our backend is layered using controller service repository setup, which we will look at in a chart coming up. So in the last demo, we focused a lot on the usability aspect from a front end perspective. So in this demo, we'll look at the backend and mainly the maintainability as that pertains to our architecture. So here's just a high level look at the architecture. As we can see, we have, as you can see, we have our front end, back end, and database all running in Docker, accessed through the browser Chrome by a user who's running it on a desktop device. This GitHub repo and Bash and everything is mostly related to deployment of the system, which was covered in more detail in the last demo. But we can see here we're mainly focused on our backend in this demo here. We looked at React last time and creating usable front end that is consistent and intuitive. This time we'll be looking at the maintainability of the backend. So as mentioned, we use a layered backend architecture. So this splits the responsibilities of different layers. So we can walk through the sequence diagram of creating a trip. So the user's gonna log into a system, they're gonna log into the application, and then through the front end UI, they're gonna fill in a trip form with valid values, and they're gonna click create on that front end UI, which is then going to call the create endpoint with a data transfer object for the trip and the user authentication. When it gets to the controller, our trip controller in the back end is going to handle this is request and response logic. So it's going to get the user from the authentication. It's going to add the user ID from that authentication to the trip data transfer object. And then it's going to validate that the input is in a valid HTTP request format as well, but that's more implicit to the controller setup. And then it's going to call our service. So this is our service implementation. It's got an interface that is just called trip service, but the implementation is where most of the code lives. This is where our business logic lives. So this is going to handle any logic that we need to do on this operation. So with create trip, first it's going to validate the trip. This is actually validating the contents of the trip. So while trip controller will validate the request, this will validate the contents. So we're going to validate that trip to make sure that it has all the values that we need. We're going to convert it from a data transfer object to an entity object, and then we're going to call save, which is going to be sent to the repository. This is going to handle all database interactions. So it's going to save that entity to our database, to our trip table. It uses a JPA repository and Hibernate to handle that. So that's a Java library that was able to be utilized there. So the database is gonna, give us a positive result, and then that created trip entity is returned to our service implementation. Our service is going to convert that entity back into a data transfer object, which is then going to be sent to the controller. Our controller will then build a HTTP response, which will have our created trip as the body, and then a 200 response code that will be sent back to the front end, which can then take that response code, display a success message, and then close the form out and add that trip to our table. And we'll see a walkthrough of that in the next section of this document, but focusing on our architecture here, we can really see that the separation of responsibilities here is key in this layered backend. This helps it be very maintainable as responsibilities are clearly broken out. It's also very testable because you can test individual responsibilities, like testing the controller through a systems integration test, and then testing the business logic through a unit test. And then repository calls can be mocked in that case to make it fairly simple, or at least more straightforward to test there as well. This also scales really well. So this was a decision made early in the project. So for smaller services like our user service, I was able to use this same structure, and then for a bigger service like the trip service, was able to use the same format there. So it creates consistency across the back end, which makes the code more maintainable. So that's it for section one. In the next part, we can move on to section two. Welcome to section two of the demo presentation. This will cover the main demo portion of this, where we will showcase features, talk about the algorithmic components, and go over some test cases. There's a lot to cover in this section, so forgive me if I move a little fast, but I'm going to try to get through everything here. So starting with the application features. So looking at sprints 3 and 4 in particular, the user stories that were developed, integrated, and tested are US4 create trip, US6 generate trip, US7 view trip, US8 delete trip, and US9 edit trip. So a lot of trip work here. You can ask why not more? You'll notice that throughout all of this discussion, US3 and US5 are missing. There was a product scope reduction that was completed, and those two were removed. And we'll get into why we chose those two at the end of this presentation in section 3. But the boilerplate here is that at the start of the project, estimates for stories were a little too low. All of the work that goes into mainly just testing these and documenting them was not factored in. It was factored in, but not as well as it could have been. And so that caused stuff to take a little bit longer. And so product scope was decreased to ensure that there was quality in our implemented features. I didn't want to cut corners to get to everything. I wanted everything to be of quality. So with that said, we can run through a quick demo of these 5 features. So it's going to be mostly happy path here. So I just want to make that clear. So here I am in the base paths application. I've logged in and I'm looking at the home page. So I can go to my trips tab here, and I have no trips here, but I can click create trip and I get a form that opens, and that allows me to create a trip here. I'm going to enter a name. We're going to call it test demo, and I'm going to enter a date. I'm going to go ahead and move forward to the Major League Baseball season. So I'm going to pick March 25th for the start, and I'm going to pick March 29th as the end. So this is just a quick weekend road trip. This is actually opening weekend of the Major League Baseball season, and so we will go ahead and create that trip. We get a success message, and then the form closes. And now I can double click this and I open it up and it brings us here to the trip details page. So what we've just walked through is the create trip user story. What we're looking at now was covered in the view trip user story. So viewing trips on this page, as well as this trip details page, is related to viewing trips. We'll notice that we have 3 main buttons up here. We can generate the trip, we can edit the trip, and we can delete the trip. We also have this trip overview section. So it has our dates that we just selected, the 25th through the 29th. And then we have these 4 here. So is it generated? No, it's not. Maximum hours per day, start coordinate, and end coordinate. These are not available, as well as no trip stops yet. However, we can go ahead and fix that by clicking generate trip. So this brings up the different values that we can enter to generate a trip. So this corresponds to our start and end coordinate, and then our max hours per day. So our start coordinate, I'm going to go ahead and enter 32.72 and then negative 117.16. So this latitude and longitude corresponds to the San Diego area. So that's where we're going to start our trip. And then our end latitude is going to be 38.58 and then negative 121.49 for our and longitude as well. And you'll notice that the ranges of latitude and longitude are listed there for the user to see, to make it clear what values need to be entered here. And then our maximum travel hours per day. So this is how many hours do we want to travel in a day? And so I'm going to say that our maximum in this case is going to be 6. So it's not going to calculate any distances that are longer than 6 hours of travel away. And we'll get into the algorithm a bit more in the next slide or two. So I'm going to go ahead and click generate on that, and we get a success, and we can see that this is now populated. So starting with the trip overview, we see that generated is switched to yes, and then we see our values that we just entered in there. And it has also generated a trip for us. So these are our trip stops. So it's starting us on March 25th at our start location. There is no ballpark or game associated with that. It's just our start location. And then the next day on the 26th, it has us in San Diego at Petco Park to see the Tigers play the Padres. On the 27th, we're in Los Angeles at Dodger Stadium to see the Diamondbacks and the Dodgers play. And then on the 28th, we're in San Francisco at Oracle Park to see the Yankees play the Giants. And then it ends us on the 29th here at our end location. So end location corresponds to this end coordinate, start location corresponds to the start coordinate, and then these are pulled from the different game and ballpark data. So that's what's involved with generating trips. So that's our US user story 6. So two more user stories to go through real quick here. We can look at editing and deleting. I'm going to start with edit because edit has something interesting that happens after we've calculated a trip. So if I edit a trip, I see this pop-up window. It's very similar to our create trip pop-up window. Um, it has these three values in here, and the reason that it doesn't have the other values is because you can edit those simply by generating a new trip. But here we can edit this trip, and we get this warning. Updating a trip's dates will remove trip stops and reset values for generation. Since generation is built off of the dates that we have selected here, if we change the dates here, then this generated trip is no longer valid because it is not the optimized trip for the date range. So if I edit this trip, if I just change the name and I click update, we get a success, the name updated, but nothing else was deleted. However, if I come in here and I change a date, say we want to leave a date earlier, and I click update, I get the success, and then it clears our generated data. So that's how the edit trip function works. And then the delete trip, pretty simple. We can click delete trip and we get this, are you sure you want to delete this trip? This is to prevent accidental deletions because once you delete it, it cannot be undone. We're going to go ahead and delete, and we see that we're sent back to the trips page and that we have no trips displaying here. Okay, moving to the algorithmic component here. So work related to the significant algorithmic component is associated with user story 6, generate trip. The significant algorithmic component is a graph pathfinding algorithm that builds a graph based on our start and end dates, our start and end location, maximum travel hours per day, as well as distance between ballparks, and then games filtered by dates, which is calculated as part of the algorithm. So we're going to dive a little bit more into the algorithmic component, how it works, and some of the code behind it, as well as some of our diagrams. So looking at a high level here, looking at a high level, we can see some overall steps for the algorithm. So this is more for the entire function of generating trips. So our step one is we're going to read in all of the ballparks. So all the ballparks get read in. Then in step two, we're going to compute the distances between ballparks using the Haversine formula. So each ballpark has a latitude and longitude associated with it. So we can compute the distances between all the ballparks. This is just how the crow flies using the Haversine formula. So it is not using any roads or anything. It's just for the MVP, it's just using the Haversine formula. And then in step three, we're going to load in all the games in a given date range. So whatever our date range is for the trip that we're generating, we're going to get all of the games that are within that range. Uh, so in that date range, that is. And then we're going to build feasible edges between games. So for all of those games that we've just read in, using that maximum travel hours per day, as well as a set kind of miles per hour at 65 for this MVP, we're going to build a graph of edges between feasible games. So if a game can be reached, if that distance to speed ratio is under the maximum hours per day, then it's a feasible game. You can get from game one to game two, so long as game two is a day after game one. So it'll never visit more than one game in a day. And so it'll build all of the feasible edges. And then in step five, we take all of those edges and then we take all the games and we build edges using the start and the end nodes. Those are special nodes because they're not game nodes, so they're not being read in, and there is no incoming edge to the start node, and then there's no outgoing edge to the end node. So it's only got to look at, can I go from start to game? It doesn't have to look at going from game to start. And then once we have all of the edges between games, as well as from the start and to the end, we can build our graph using all of these edges. So it puts them all on a map, and then we can pass that map on to traverse the graph and find the optimal path. We're going to be looking a little bit more at that in a second. Finding that optimal path is using a depth first search, and again, we'll dive into that, even looking at the code in a bit. Sorry about that. And then in step 8, once we have the optimal path, we can format that path object into our trip stops list of trip stops, which can then be returned to the user. And so since we've done that here, we can take a quick overview here. I have these diagrams here. And so this is what we've just looked at there. This diagram here is in regards to building the graph, and I'm actually gonna skip over that a little bit, or I can run through it real quick, but we're going to gather all the games, and then for each pair of games, if they are the same game, then we don't do anything with them. If the date of game 1 is less than the date of game 2, so game 2 is after game 1, then we move on and we check the travel time. So if travel time is less than or equal to days between games times max travel hours per day, then it's a feasible path and we can add that edge to the graph. Otherwise, it skips that combination. And so here's our search algorithm here, and we're going to go through the code a bit as well. But essentially what it's doing is it's doing a recursive depth first search. So what it does first is it checks, is the current node the end node? So is the node that's being passed in the depth first search the end node? If it is, we're going to return a path object with a list of all the nodes, which in this case is just the end node, as well as a total games visited, or game seen and ballparks visited. So those numbers are going to be used for tiebreakers when paths are the same length. And then if it's not the end node, then we're going to check to see if this node has already been explored, if this path has already been explored. If it has, then we're going to return the subpath of that node, and if it hasn't, then we're gonna keep searching it. So we initialize a best path in that set, and then for each edge in the graph under that node, so for each outgoing edge of that node, we're going to run through this loop. So we're going to loop through all the edges of the node here. So we get the next edge, which is going to be edge.destination. So that's our next node for each edge. So here we're in a loop. So I'm going to talk more from the edge's perspective than from the node's perspective. So we get the edge destination, we get the destination node for that edge. New park, so this is tracking which ballparks we've visited. So the goal is to maximize the number of ballparks we have visited. So if this is a new park, meaning that parks does not contain the next node's ballpark, so our list of parks, we haven't visited that park yet, then we set this new park to true. Or we set it to false, either one. It's just tracking, hey, is this next node, is the destination node on this edge a new ballpark? Because then we want to potentially prioritize that path. So then we get a candidate path. This is where we do the recursive bit here. So we pass DFS, and then we do next here. So that's our next node, and then parks here. Which is our list of ballparks that we visited. And so then after that, we get that candidate path. So again, we're doing recursive follow through there, but we'll get a candidate path at that point, and we'll see kind of where that comes from as we continue. We get that candidate path, and then it moves on. So we have a sub path there that is a candidate for our best path. If we had a new park there, then that's true. We remove that next dot ballparks from parks because we want to make sure that when we move on to the next edge in this loop, that we're not counting a ballpark from the destination node of the previous edge. So that's why we remove it there. And then we do some tiebreaker calculations. So we set our games to candidate path.games plus 1, since candidate path is not going to contain the current node that we're looking at. And then we set our parks to candidate path.parks plus, if it's a new park, we add 1. If it's not a new park, we don't. So that's going to track how many parks this current path has visited. Next, we do a check to see if this is going to be our optimal path for this kind of branch. So if games is greater than our best dot total games, so we prioritize games first. So we want to see as many games as possible. So if this path has more games than our best paths games, or if games and is equal, so if they both, if our best and our current have the same number of games, then we look at ballparks. So if ballparks dot size is more than our unique ballparks, so we want to prioritize paths that see more ballparks. So, for example, I could sit in San Diego and see, you know, 12 games in 12 days, but I'm seeing them all in San Diego. Whereas I could maybe see 12 games in 12 days by driving around a bunch, and I would get to see other ballparks. So that would prioritize the driving portion. This is mainly to filter out paths that just kind of sit in one spot for a bunch of time. Um, so if that is true, if our candidate path is a more optimal path than our best path currently is, then we add the node to our candidate path, and then we set best to our path. So we you know we set that path to our best. And then if it's false, then we go back to the loop and we continue the loop. And then once that loop is finished, so once we've completed the loop, we can add the best our optimal subpath to our list of subpaths, and we can return the best path that we found, and that's kind of where this candidate path is coming from when we're running the DFS. So that's a lot. We can kind of, since we kind of went into detail on that, we can look at the code to see kind of what this looks like in practice. I won't go into as much detail here, just since we just covered it. But here's what a path object looks like. So looking at the path object, we have path, total games, and then a set of ballparks. It says integers because it's going by the ballpark ID. So we can see how that how this path looks and what's returned. And then we have this graph object. So this graph object is going to it's got some values that are hard coded, mainly the start node ID and then the end node ID. They're set to negative values. This is just for to track by ID. If we didn't have IDs, it would be harder to track the start and the end nodes, as well as the locations here. And then we can look at the concept of travel days as well, which is kind of done after the path has been set to insert travel days. When it takes more than one day to go from one destination to the next, it'll insert a travel day. That's just pretty basic division operation, just to you know, if it's divided by, you know, you do a mod on it. If there's a remainder there, then you do a division, integer division, to find how many travel days are between paths. So here's our subpaths hash map. So this is you know, doing some storage of those subpaths so that we're not recalculating paths over and over again. And then, you know, we have methods to build out our graph, but what we're really concerned with here is that DFS algorithm. So we can see here the first check it does is it the end node? If it is the end node, then we're gonna return a path of node with 0 total games and our copy of our ballparks list. We have to make a copy of the list because things get messy if you don't. So that's just a list of ballparks, and then the total games visited at this point is 0 because our path is just the end node. Next, this is again just more getting some ballpark list logic. So, you know, if our subpaths has this node and it contains the ballpark list, then we're going to return that subpath. So this is just kind of going to skip a lot of the logic if we've already completed it. If not, you know, we set the best to a new list. We use a negative value here so that the initial, the first thing found is a more optimal path than the initial set. We have to check if it's a real game. So this is saying, is it not, make sure it's not the start or the end node. So make sure that this node is not the start node. Otherwise that threw off some of the calculating logic where it was calculating the start node as a game visited. which it's not. So we want to make sure that we're not doing that. And so we're going to loop through the edges here of that node. So we're going to look at we're going to do a graph.get if there is no if this node has no outgoing edges, then which is possible, then we return an empty list so that we don't loop through anything, and then this best path just gets returned, and that's fine because this -1 is going to indicate that that this is not an optimal path. And if there are no optimal paths, if there is no path from start to end, then this will get returned, and that'll just tell us that the trip is not feasible. So yeah. So then in this loop, we can see that, we set that next. We build out the ballparks list, and then we run recursively the DFS algorithm. Here we set our games in our parks, and here we do the comparison to see if this is a more optimal path. And then we set our subpaths, and then we return that best found object. So we also have this get best trip. This is kind of the next step up. It calls that DFS, and then it does the conversion from a path object to a list of sorry, to a list of to trip stops. So we can see it building that trip stop list here. And it's going to return the trip object, so it's going to create the trip stops, and then it's going to add that to our trips, to a trip object, a trip DTO object here. So yeah, and then we have this trip utilities class. This has a lot of trip utilities. We can see our haversine formula there. We can calculate our distance here. We can see populating the ballpark map. So this is reading in all of the ballparks. We have some conversion methods, some mapping methods to convert a node to a trip stop, and then getting days between nodes. We have a function for that. We have a function to build the distances, the map for distances between ballparks, and then we have a build graph function, which will build our graph from our games, our distances, and our max travel hours per day. And then we have a function to add the start and the end edges to that graph. So it takes the graph, it takes the trip, and then the games and the ballpark distances, so that it can calculate the all feasible paths from start to games and from games to end. And then we have this generate trip function, which kind of pulls it all together, calls a lot of these methods, starts by populating that ballpark map, and then calculating distances, then builds out that graph, adds the start and the end nodes, sorts the edges by end date. That's more just yeah, to sort things before we call get best trip. And so that's pretty much it for the algorithm there. I know that's a lot. It's probably a high level view. There is more information in the SRS, in the software requirements specification, that we can go through if you want to go through that on your own time. So moving on to some of our testing. So this is our testing report. I'm going to kind of, again, move through this quickly. There's a lot of tests involved with these 5 user stories that were covered in sprints 3 and 4. So we're not going to be able to go through all of them, but I have pulled out a couple of them to look at. So start by looking at the traceability matrix here. So we can see that at this point, our MVP is complete. And so all of our tests are completed and passing. We're more concerned, we have user story 1, 10, 11, and 2 here. Those were completed in the first half of the project and were covered in the last demo. So we can kind of look at the ones for user story 4, 6, 7, 8, and 9 as we go through here. So we can see a variety of back-end tests, front-end tests, systems tests, and user acceptance tests for all of these user stories here. And we can see that they're all passing here, and that was great. That I spent some time the last week or 2 weeks making sure that our tests were passing, that our system was up and running before completion of the MVP. We can see that all unit and systems tests are automatically run. We'll look at a pipeline running those in a second here. And then we have our user acceptance tests. These are all manually run since they're from a user's perspective. Ran through all of those yesterday and confirmed that they are all passing. Our traceability matrix has a lot of mapping information here. This is a really good tool to have when looking at the test report. Because the test report will have things like test ID and maybe user story. But if you want to map to where the actual code is in the file, you can map here. You can map the architecture element. You can map the commit that it was part of. And so this traceability matrix is really helpful. The functional requirements here as well, but also if you click the link to it looks like that click didn't work. But if you click the link to the user story, the functional requirements in the user story description as well. So yeah. So that's our traceability matrix. I mentioned a sample of unit and systems tests for each user story. So we can go ahead and look at that here. I'm not going to go over the user acceptance tests simply because the happy path for those is basically what we just did looking at the application features. And so I want to make sure that we kind of highlight some unit and systems tests. I pulled a sample out. We may not have time to go through all of these, but we can kind of look at what we're doing here. So looking at create trip here, this is a pretty good sample of what all of our tests look like throughout all the user stories. So we have a backend test here, creating a trip with no trip stops. So the goal here is that we are creating a trip, and then the trip has no trip stops. So we want to make sure that when it's returned, the DTO object has the correct values and also an empty list for our trip stops here. So we're mocking the repository call, and then we're so that when its save is called, it returns an object that's expected. So again, we're testing here the business logic in the service. And then we have a front-end unit test here to that the create trip form shows an error. So we're mocking a backend call here. The backend's going to return with a 400 method via mock. And we want to make sure that an error message is showed on the create trip form. And so it's going to check for that element when it does so. And then a systems test here, creating a valid trip. This is pretty much what we just ran through in manually when creating a trip, except this is doing it with a Cypress script. So, it's filling out values, it's hitting the create trip button, opening the form, filling in values, clicking create. It's going to make sure that the backend is called, and then it's going to check for that success message. It's going to check that the backend succeeded, and it's going to check for that success message, check that the form resets and is closed, and that the new trip shows in the table on the trips page. I have more samples here for the other user stories here, but looking at our clock here, I think we're not going to have time to go through all these, but they're very similar to what we've seen with Create Trip. Just testing edge cases and both happy path and error paths, both with the unit tests and the systems tests. So actually, let's find a systems test that is not happy path. Here's one. So generating an invalid trip. So if we open that generate trip form and then it opens and we just click generate without entering any values in, we should get an error on that form. And we're checking to make sure that the error shows and that the form does not close. So yeah, we can also look at these tests passing in our pipeline. So I ran this pipeline against our main branch this morning, so I can open this up, and we can see this does a build and a deploy and everything, but it also runs all of our tests. So we can look at the front end tests here, and we can see there's some warnings here. That's just that's just an issue with Jest. It's not actually failing our tests here. But we can scroll down to the bottom and we can see, that the tests, all 8 suites passed, and then 28 tests passed in all of our suites. So it also gives us coverage results here, although it also uploads coverage results, and we'll go over that coming up. So test analysis. So test progress is complete. We had a mix of unit, system, and user acceptance tests added each sprint. Coverage goals have been reached as well. So testing is considered complete for the MVP. Number of tests, we had 142 total tests for the whole project. I wrote a mix of user acceptance tests and back and front end tests and systems tests. And so, I can kind of show you that in the traceability matrix here. This first row is a column header row, but we have all 142 tests here, it goes to 143. So if you remove the header column, we see all of this. Also, since this is in Excel, you could sort by any of these rows. So the order of this doesn't particularly matter too much. I have it sorted by user story right now, but that's doable if we want to view, say, in order of the test ID, so that all the back end and front end and systems and UATs are all grouped together. You can do that as well. So just looking at a code coverage analysis here. So starting with the back end. So this is in JUnit code coverage calculated with JCocoa. And so we can see that we're sitting at 87% on our instructions and then 77% on our branches. So this is really good code coverage. I'm pleased with it. The graph objects look like they could be tested a little bit more, and then it looks like there's one branch missing from the model, that one, and so it's giving us that 50%, but again, relatively small compared to the rest of the application, and so that 77% is covered in that branch coverage. And then looking at our front end tests, we can see similar results here, everything above 75%, which is great to see. Again, that lowest being kind of in our pages and our branch coverage. It looks like we're sitting 49 out of 64. So if there were space for improvement, that's where I would look. However, I've hit the goal of 75%, which was the threshold set in my non-functional requirements. So yeah, that's it for section 2. Now moving on to section 3 of the demo, we're going to look at some wrap up and reflection, starting with a project review. So looking at the project as a whole, with emphasis on the last 2 sprints, but also the project as a whole. Some things to note: product scope was reduced to remove 2 user stories. This is US 3 viewing a list of ballparks, and US 5 adding trip stops to a trip. So the reason that these 2 were chosen is that viewing a list of ballparks is just a nice to have. It was just a cosmetic addition that was deemed the lowest. It was the lowest priority story from the beginning, and so it was removed. But it was a relatively small story. User story 5 was removed because it was not central to the goals of the MVP. This was a manual trip creation, so if you wanted to manually create trip stops on a trip that aren't automatically generated, then you would be able to do so. This was a lot of work that was not central to the goal of the system, which was to generate trips. So this felt like it was prime for removal from the MVP, but a really good candidate should I decide to continue to work on this project for personal use. This would be high on my list of things to add, but it was just simply not key to the MVP, as well as being a relatively large user story. And the reason that scope needed to be reduced was due to an underestimation of stories, as well as various technical difficulties, particularly early in the project with getting things set up. I think establishing the pace of the project is another thing that pace probably picked up particularly late in sprint 2, but then through sprint 3 and 4. Had that pace been from the start, I might have been able to get through at least user story 3, maybe user story 5. However, the pace at the beginning of the project was probably not where it needed to be, as I figured out kind of best practices as I moved on. And then kind of some changes that were made late in the last 2 sprints, in sprint 3 and 4, are that tasks were added to upkeep documentation. Kind of at the end of sprint 2, there was a push before the first demo to get those documents started, and so tasks were added to upkeep the documentation throughout sprint 3, and then sprint 4, even larger tasks were added to make sure that all the documentation was done. And I can say that as of right now, all documentation is done and is set to be submitted on time. So looking at a burn-up chart for the current sprint, sprint 4, this shows a pretty good idea of what the velocity kind of looked like and the pace. So we could see some plateaus here. Sprint 4, I did get sick in the middle of sprint 4, and so that is shown kind of at the beginning here. It's either this plateau at the beginning. I think it's this plateau right here is when I got sick. It was about the week before Thanksgiving. I got sick, and so pace kind of slowed that week. I would have liked to see a little bit more of a step here or there. However, you could always see a flat at the beginning of the sprint. This is typically because sprint planning is taking place and tasks are just being started. They're not closing quite yet. And so that's why you see that gap there. And then, the first set of tasks start to close out. They had some rollover from sprint three. And so that's kind of what's closing here, and why there's a big jump is that there was a little bit less work to do for those. And so that they kind of all closed out at once. There's also some user stories in here that rolled over since there were tasks that rolled over. And so those user stories are being closed. And that's why you see a jump there. When a task closes, if it's the last task in the user story, both the task and the user story close. So pretty steep jump there. But otherwise, for the most part, like this week here is pretty emblematic of how this pace typically goes. The piecemeal. We see a task close, it's being worked for a day, it closes. A new task is being worked for a day, it closes. So it looks like maybe a user story closed here, and then it continues on before kind of closing out right at the end of the sprint. We did hit our goals for all of our planned tasks in sprint four. So continuing with this project review, looking at some challenges faced. I talked about this in demo one as well, but wearing many hats in a solo project is difficult. Having to be a tester, an architect, a developer, systems engineer, it's a lot. Particularly documentation of the testing was something that I found to be relatively time consuming. Just needing to document all of the tests and all of the test results, and in the traceability matrix, and tracking UAT results at the end of each sprint. Like this became a lot more overhead than I think I was anticipating. But as the sprints moved on, I think by the time sprint four and sprint three rolled around, I had a pretty good handle on it and was able to do that. And that kind of keys in with balancing overhead tasks like general documentation with tech debt and other user story work as well. It's all a balance work. And then, additional challenge faced here at the end is that I got sick during sprint four and was a little less productive for a week. Luckily, I was able to make up that time with the week of Thanksgiving, which was not included in the sprint planning, but was able to be worked regardless. So some improvements going forward. Should I continue this project, or should I, take these skills that I've learned into the workplace? Better estimation for new user stories, particularly from the start, would be the key that I would take away. Underestimating how long stuff was going to take, particularly the overhead work like documentation, testing, and non-development tasks. Those underestimates definitely caused some issues, as I was planning in my head from the beginning, implementing this will take this amount of time, and wasn't factoring in the immense amount of work that needs to be spent particularly documenting tests. I was definitely factoring in test work, but maybe documenting them could have been better. So looking at our velocity here, so this is across our four sprints, we can see that sprint one is low. As I mentioned, I had some pace issues from the beginning, simply just under story pointing how much time I needed to work on the project. And I learned that pretty quickly. You see it jump up in sprint two. Sprint three is a little lower. This is simply because I had some rollover tasks. That's why sprint four is higher as well. So if you took the average of these, then that would be about where you would expect it online with sprint two. So sprint three is lower because some tasks were not completed, and so they were moved to sprint four, and credit for those tasks gets placed in sprint four. However, most of the work was probably completed in sprint three. So continuing to look at code frequency. So this previous one is task closing out. So tickets closing. This one's looking at coding frequency. So this chart in the top right is for the entire project. However, a ton of code. You could see almost 700,000 lines of code was added at the beginning. This is mostly configuration files, and as I set up Docker and Spring and Jest in the front end, and a lot of this is generated code, and it really threw off. It looks like there's no code being done here, but it's just the scale of it. And so here's a zoomed in version, kind of looking at the sprint three and sprint four. In particular, and you can see there's this big spike here. I believe that is implementation of the significant algorithmic component. Maybe I did some. I know I was having trouble filtering out some code coverage stuff from Git, and so this could be a lot of code coverage files as well. But we can see pretty steady, and I have that open here, so I can zoom in here and look at kind of as the weeks progressed, how things looked, and we could see 500 lines, 3,000 lines, 1,600 lines, 21,000 lines, 900 lines. So like this is pretty stable consistency for most of it, if you remove this big spike at the beginning from the scale. So some last lessons learned here, kind of as we close out this demo and this project. Yeah, lessons learned: keeping a steady pace, a maintainable pace is really important. But also making sure that that pace is where it needs to be to get everything done. You don't want to slack for a week and then push for a week. You definitely want a steady, maintainable pace. Being thorough in definition of done for user stories really helps with that because it helps planning, knowing everything you need to do to finish that user story and planning that all out at the beginning helps kind of plan that pace. Setting a strong foundation again, like planning is just so important in this, and estimation is key, especially at the start of a project. Better estimation is going to come with more experience. As I worked tickets and tasks, I had a better idea going forward about what work needed to be done to complete tickets. And so with that, that is the end of demo 2 here. Thank you for watching, and I thank you for helping everything that I've done so far. Hope that the project looks good. Thank you.